Now let's look at an example where we simplify a radical with an odd index, including both coefficient and two different variables. So let's go ahead. We have a cube root here. What we should probably do first is split up the cube root. The 5 is just the coefficient. It will stay out front, and we'll deal with it later. So if we split it up into the cube root of 64 times the cube root of x cubed times the cubed root of y to the 5th. All right, so let's first start off with the cubed root of 64. So we have a cube root here. We're trying to figure out what's the biggest perfect cube that would divide evenly into 64. Well, it turns out 64 is a perfect cube, and 4 times 4 times 4, or 4 to the 3rd power, is 64. So let's rewrite the cube root of 64. It's really 4 times 4 times 4, which is 4 cubed. And the goal is to get an exponent of 3 here. And the reason for that is when you take the cube root of something cubed, right, they're inverse operations, so they cancel out. So it's going to be a little different with the variables here, but let's check this out. So we have the cubed root of x cubed. Well, it looks like x cubed is already a perfect cube. So when we take the cube root of x cubed, what ends up happening is they cancel out and we just get x. So now it's a little more complicated when we go to the cube root of y to the 5th, and the reason why is because we have to manipulate that y to the 5th so that we have a power of 3 somewhere in the radicand. So can we rewrite that y part to be something to the 3rd power? And using the properties of exponents and power to a power is just not possible. So we're going to have to think, how can we rewrite y to the 5th power to have a y cubed? Well, we have to remember our exponent properties. So if I need a y cubed, right, because I'm trying to simplify, y cubed times y to the what power would give me y to the 5th. Well, when we multiply variables, we add their exponents. So 3 plus what is 5? Well, that's got to be 2. So y cubed times y to the 2nd power is equivalent to y to the 5th power. And the reason why we did that is so we can simplify and kind of bring that y cubed outside the radical. All right, so now let's simplify. That 5 is just going to stay out front for now. The cube root of 4 cubed would be 4, because 4 is the cubed root of 64. We have 5 times 4 times x, which already simplified. Now we're going to separate this last radical to the cube root of y cubed times the cube root of y squared. All right, so just like how kind of when we were simplifying square roots, where you simplify into the perfect square and the non-perfect square, and the perfect cube, non-perfect cube for cube roots, this is what we're doing here. So what's going to end up happening is one of those roots is going to stay, but one of them will be able to simplify and something will come out. So let's do this first. So the cube root of y cubed, well, that would just be y. And then we will leave the cube root of y squared since it cannot be simplified any further. All right, let's bring the x down, and we can do 5 times 4, which is 20. So now we have 20xy times the cubed root of y squared. So I'll write that a little better. This will be the final answer, because we cannot simplify any further.